So in this video, we are going to see the biomass and biomass energy. So this is the last energy source in introduction to energy sources. In next videos, we are going to see the energy conversion devices like turbine, then pumps, windmill, and compressors. So this is the last energy sources, that is biomass and biomass energy. So we'll see these different biomass and biomass energy. Now, what is meant by this biomass or biomass energy? If you see, a biomass is a organic, meaning it is made of material that comes from living organism. So biomass, it is a organic material that is made up of or comes from living organism, such as plants and animals. The most common biomass material that can be used for biomass energy or conversion of energy, it is plants, woods, and waste. These materials, biomass materials, that is plants, woods, and waste, these are called as biomass feedstock. Biomass feedstock. Now, this biomass energy can also be non-renewable energy source of energy. It is not renewable. It is a non-renewable energy source. So biomass contains energy first derived from sun. Then plant absorbs this sun energy by using photosynthesis method and convert carbon dioxide and water into a nutrition that is called as carbohydrates. So the energy from these organisms that can be transformed into usable energy by using either direct or indirect method or direct or indirect means. So biomass, it can be burned directly to create heat energy, or biomass is used to convert it into a electricity, or it is processed into a biofuel. So it is indirect use. That is, biofuel is indirect use, and heat and electricity is the direct use. So what are the various sources of, say, this biomass? It may be sewage, municipal sewage. It is agricultural crops and residues. Then forestry crops and its residues. Then we have industrial residues. We have animal residues and municipal solid waste, that is MSW. So these are the various sources by which we can have a biomass. So these are the sources of biomass, and we use this biomass to biomass energy to create energy. So we have biomass power plant will be there. So from that we get carbon dioxide. Carbon dioxide is trapped or absorbed by trees or plants, and these trees and plants, it forms a biomass, and again from this biomass there will be a biomass power plant. So this cycle gets complete. So this is the cycle for biomass energy. Now we'll see the different methods for biomass conversion of biomass into biomass energy. So if you see, there are mainly three methods conversion of biomass into bioenergy. That is, these are the methods of thermal conversions. So first method is combustion. So there is a direct combustion which forms energy and vapors. Second, another method is gasification, where it forms a fuel gas that is called as tar or charcoal. And third one is pyrolysis, so from which we get biofuel and bio-derived charcoals. So we have biofuels like ethanol, methanol, biodiesels. So these are the where we can convert biomass into biomass energy. So there is a direct combustion will be there. There is a gasification process will be there. There is a pyrolysis process. There is a torrefaction process is also there. So by which, so these all processes are the thermal conversion process. So by which from thermal conversion, we convert biomass into biomass energy. Another method to convert this biomass into mass energy, it is the biological or biochemical conversion. And third method, it is the biofuels. So we'll see this all methods or ways to convert biomass into biomass energy one by one. So first method, it is a thermal conversion. Now, what is meant by thermal conversion? So biomass can be burned by thermal conversion and used for the energy. So by burning of this biomass, we use this energy for different purpose. Now, thermal conversions, it involves the heating of biomass feedstock. Now, biomass feedstock is nothing but the plants, woods, and waste that is known as biomass feedstock. So, thermal conversion involves the heating of this feedstock in order to burn, in order to dehydrate or stabilize it. So the most familiar biomass feedstock for thermal conversion are raw materials such as MSW, that is municipal solid waste, and scraps from paper and lumber mills. So there are different types of energy are created either by using this thermal conversion process, like direct firing will be there, then there will be a co-firing will be there, pyrolysis will be there, then gasification will be there, anaerobic decomposition will be there. All are the thermal composition or thermal conversion methods. Now we'll see the first method, that is called as torrefaction. So before biomass can be burned, it must be dried. So this process of drying the biomass, it is called as a torrefaction, and this is chemical process for drying the biomass. It is called as a torrefaction. So during torrefaction, the biomass is heated about 200 to 320 degrees Celsius. That is approximately 390 to 610 degree Fahrenheit. The biomass dries out so completely that will loses the ability to absorb moisture. So it will absorb or dehydrates all the moisture during this heating process. And it will loses about 20% of its original mass. Okay, so mass of this biomass gets reduced by 20%. But the 90% of energy gets retained. So out of 100% energy, we get 90% of energy, and the mass is reduced up to 20%. So there is a loss of energy and mass that can be used, and for that we require a fuel for this torrefaction process. So we require fuel for heating. So external fuel is required for heating and all that. So during this torrefaction process, the biomass becomes a dry and blackened material. And this dry and blackened material, it cannot absorb the moisture. It loses the ability to absorb the moisture. So biomass become dry and blackened. Then it is compressed to form the briquettes. So by heating, it becomes dry and blackened material. Then again, we compress this dry and blackened material to form a briquettes. Now, biomass briquettes are very hydrophobic. Hydrophobic means there is no ability to absorb any moisture. So its meaning is it will repel the water. It will not absorbing the water. So this makes possible to store them into a moisture area. So if we store these briquettes in moist area, uh, you can store because it will not absorb any water. Then the briquettes have very high energy and high density, and they are easy to burn by using direct firing or by using co-firing. So this is the first method of thermal conversion, that is torrefaction. So we'll see the process of this torrefaction. If you see, there is a raw mass material. We reduce the moisture from this raw biomass. We convert it into a solid biomass by drying. So we heat this raw biomass and we reduce the moisture. Then we reduces the volatiles and tars from this solid biomass to becomes a torrefied biomass. Okay, so this is the method of torrefaction. Now we have another method that is called as another method of thermal conversion, that is direct firing and co-firing. So these are the two terms. One is direct firing and another one is co-firing. So after torrefaction, these briquettes, the most of briquettes, they are burned directly, and the steam produced during this firing process powers the turbine, and which turns the generator and that produces the electricity. So by direct firing using this torrefied biomass, that can be used to steam power plant. Then this electricity that can be used for either manufacturing or to heat the buildings. Then second method, it is the co-firing. So biomass, it can be also co-fired or burn with some fossil fuels. Co-firing means we can burn this torrefied biomass with other types of fossil fuels, that is called as co-firing. So biomass is most often co-fired with coal plants, that is in thermal power plant or steam power plants. So co-firing eliminates needs of new factories for processing the biomass. So if we co-fire this uh, torrefied biomass with another fossil fuel, then we does not require any new factory or new production for processing of this biomass. So co-firing also eases the demand of coal. So it also reduces the demand of coal, and because of it reduces the demand of coal, it also reduces the amount of carbon dioxide and other greenhouse gases released by burning the fuel gases. So we reduction in their burning of fossil fuels, and that will reduces the carbon dioxide and greenhouse gases. So this is the second method of thermal conversion, that is it may be this torrefied biomass, it may be direct firing, or it may be a co-fired. Next method of thermal conversion, it is called as pyrolysis. It is the famous method, that is pyrolysis. So pyrolysis is a related method of heating biomass. So during pyrolysis, biomass is heated up to 200 to 300 degrees Celsius, that is 392 to 570 degree Fahrenheit, without presence of oxygen. So we heat this biomass without presence of oxygen. And after this pyrolysis, the pyrolysis process produces a dark liquid that called as pyrolysis oil, and a synthetic gas, it is called as syngas, and a solid reducer residue, it is called as a biochar. So by using pyrolysis process, we get pyrolysis oil, then that is the liquid fuel. Then we get a gaseous fuel that is called as synthetic gas, and we get a solid fuel or solid residue. It is called as a biochar. So all these components, that is pyrolysis oil, synthetic gas, or biochar, it is used for energy. Now, pyrolysis oil, sometimes it is called as a bio oil, or it is also called as a bio crude. It is a one type of tar. So it can be combustion of this bio oil or bio fuel to generate the electricity, and it is also used as a component in other fuels and plastics. Another, the syngas or synthetic gas can be converted into a fuel, that is natural synthetic natural gas, and it can be also used to convert this synthetic natural gas. It can be converted into a methane and used as a replacement of natural gases. So by using this pyrolysis methods, we get different types of fuels. It may be a solid fuel, it may be a liquid fuel, or it may be a gaseous type of fuel. So that process is there. So biomass, there is a drying is takes place, that is at 100 to 150 degrees Celsius. The pyrolysis is takes place at 200 degrees Celsius to 500 degrees Celsius. And from that pyrolysis, we get gases such as carbon monoxide, hydrogen, methane, H2O. So this is the gas type that is called as a synthetic gas, or syn gas, or synthetic natural gas. Then from this pyrolysis also, we can generate the liquid fuel. That liquid fuel, it is called as a tar, in terms of tar, in terms of oil, or in terms of naphtha. Then this liquid fuel, the gas solid reaction, we are having a temperature about 800 to 1200 degrees Celsius. By cracking, reforming, combustion, so by using this, we convert this into an again gases like CO, hydrogen, carbon dioxide, CO2, then H2O, methane, then cracking plus 5% of products. Now, this pyrolysis, it can be oxygenated compounds with the gases, produces the phenols and acids. And we have a solid fuel by this pyrolysis process. It is called as the biochar, that is char or biochar. So biochar gasification reaction will be there, that is takes place at 650 to 900 degrees Celsius. Again, that will again forms the gases like CO, H2, CO2, H2O, methane, and residues of carbons. So this is the pyrolysis method. From that, we can produce the gaseous fuel, liquid fuel, then solid fuels also. So this is the pyrolysis process. Next process of thermal conversion, it is called as a gasification. Now, in gasification, biomass can be directly converted into energy through gasification process. So during gasification process, the biomass feedstock, it is heated more than 700 degrees Celsius with the controlled amount of oxygen. And the molecules of this biomass is break down, and it produces a synthetic gas and slag. So synthetic gas is a combination of hydrogen and carbon monoxide. And during gasification process, the syngas is cleaned of sulfur, particulates, mercury, and other pollutions or pollutants. Then slags forms a glossy or molten liquids that can be used to make uh, shingles, then cement or asphalt. Then industrial gasification plants will able to convert more than 350,000 tons of municipal solid waste into enough energy of that will power the almost 50,000 homes. So by this is the industrial gasification process. So these industrial gasification plants are being built over the world, the Asia and Australia. They are constructing and operating this most of the plants. Although one of the largest gasification plants in the world is currently under construction, that is in England, and this plant is will eventually convert this 350,000 tons of municipal solid waste into a energy, and that will power almost 50,000 homes. So this is the methods of gasification. So in gasification, there is a steam, ash, oxygen, then other this process is there, and from that we can convert this gasification process biomass into hydrogen by using a different ways to convert this biomass into hydrogen. So this is the thermal conversion process. Now we have biochemical conversions. Now there are two types of biochemical conversions. One is anaerobic decomposition and another one is the fermentation process. So in anaerobic decomposition, it is the process where microorganisms, usually bacteria, they break down the materials in the absence of oxygen. That is called as anaerobic decomposition. So anaerobic decomposition is the process where microorganisms, usually bacteria, break down the materials, that is biomass, in the absence of oxygen. And in aerobic decomposition is important process in landfills where biomass is crushed and compressed and creating anaerobic environment, that is oxygen poor environment. And in anaerobic environment, biomass decays and it produces a methane, which is a valuable source of energy. Okay, so these are the say anaerobic digester is there. So different types of it may be a slurry or manure, food or the amenity waste, crops or its residue is passed into this anaerobic digester, where from this we get a methane gas that is called as a biogas, and the digest will be there. So from this biogas we convert into a biomethane. From this biogas we convert biogas into a power, that is electricity. Then by combustion of this biogas we convert it into heat. This biomethane, it is used for a gas grid, and again this methane is used for as a transportation fuel. So this is the anaerobic decomposition process. Another process of biochemical conversion, it is fermentation. So in fermentation, it is a process which in which sugars are transformed into new products. Sugars are transformed into new products through chemical reaction carried out by microorganisms. This produces biofuels such as ethanol, butanol, acetone, isobutanol, lipids, and other value-added biochemicals like organic acids, which exploiting fungus, yeast, and bacteria. So there are two types of fermentation. One is lactic acid fermentation, and another one is alcoholic fermentation. So in lactic acid fermentation, we use a lactose sugar, and that will convert into energy. And from that, we get, by using fermentation process, we get vinegar, then a kefir, yogurt, cheese, then probiotics and valuable end products. And by using alcoholic fermentation with this glucose, we get breads and cakes, medicines, and biofuels. So this is the fermentation process. So this is the biochemical conversion. Now we have next conversion method, that is the biofuel. So biofuels are the liquid fuels that is produced from renewable biological sources, including plants and is allied. The biofuels offers the solution to one of the challenge of solar, wind, and other alternative energy sources. So these against biofuels, they are made up from food sources such as sugar, starch, then vegetable oils, or animal fats using conventional technology. And common first generation biofuels, it includes bioalcohols, biodiesels, vegetable oil, bioethers, and biogas. So these are the biofuels. So biofuels is known to be very efficient alternative to these fossil fuels. There are many other advantages of biofuels as well, as because biofuel, it can be used for transportation. Then biofuel, it can be used to provide hydrogen as clean energy source. Biofuel, it can be used as a cleanup oil. Then biofuel, it can be used as a fuel for cooking and very much. So these are the various application of these biofuels. So it can be used to running the cars because less carbon dioxide will be there. Then it is used for transportation purpose. Then feedstock will be there. So it is a one renewable source of energy, that is the biofuel. And the most commonly used liquid biofuels that is used in transport, that is ethanol and biodiesel. So 20% of ethanol, they can mixed with the petrol, that can be allowed by the government. So again, biodiesel, it is used to run the vehicles. So ethanol is a type of alcohol that can be produced by using feedstock containing significant amount of sugar, such as sugar cane, sugar beet, or starch, or maize, or wheat. So by this methods, we can produce is the ethanol and biodiesel. So these are the biofuels. Now we'll see the advantages and disadvantages of this biomass and biomass energy. So first we will see advantages. So biomass is clean and renewable source of energy. If trees and crops are sustainably farmed, they can offset the carbon emission when they absorb with carbon dioxide through the respiration process. So carbon emission, it can be reduced. Next, the biomass feedstocks such as switchgrass, they can harvest on marginal land or pastures where they do not compete with your food crops. Unlike other renewable energy sources like wind, solar, the biomass energy, it can be stored within the organism and it can be used when it is needed. So these are the some advantages. Disadvantages: the biomass feedstock are replenished as quickly as they are used. So they are exhaustible. They cannot become non-renewable, or they can become the non-renewable source of energy. Why? Because we are using this biomass feedstock directly by using direct firing or co-firing. Most of biomass require the arable land to develop. That means the land used for biofuel crops such as corn, soybeans are unable to grow other types of food and provide natural habitats. So the food land, it gets reduced. Third, the most biomass plant require fossil fuels to become it economically efficient. Again, the biomass has very lower energy density than the fossil fuels. So burning of biomass releases the carbon monoxide, carbon dioxide, nitrogen oxide, and other pollutants and particulates. So these are the all advantages and disadvantages of biomass and biomass energy. So in this way, we have completed all energy sources, starting from thermal or steam power plant, that is chemical energy, then we have hydro energy, then we have nuclear energy, then solar, wind, tidal, hydrogen, biomass. So we have covered all these energy sources uh, of this first unit, that is introduction to energy sources and its conversions. So thank you for watching this video, and also please subscribe my channel to get more update on the videos. Thank you very